All right, so Unit 3, Day 3 and 4, we're going to get into, of course, some more applications of polynomials. So you're going to need to make sure you have your calculator with you today, and always feel free to pause the video to put numbers into the calculator to make sure you're getting the same answers that I am. I'm not going to spend the time pulling up the calculator and showing you how to do that, assuming that you're pretty good with that situation. All right, so as a warm-up, we're going to go back to yesterday and just make a list of our possible rational zeros of this cubic polynomial. So if you recall, it's the factors of 18, factors of the constant over the factors of the lead coefficient. So for 18, I'm going to have quite a few, 1, 2, 3, 6, 9, and 18. Don't forget your plus minus for the factors, which gives you double the amounts. And then plus or minus 1 over plus or minus 2. So if I expand that list, I have positive, negative, and remember I just start with my numerators and successively put those over 1 and then over 2 and reduce as necessary. So first thing I'll have is 1 and 1/2. And then I have 2 over 1 and 2 over 2, which is 1. I already have that one. 3 over 1, 3 over 2, 6 over 1, 6 over 2 I already have. 9 over 1, 9 over 2 I need. 18 over 1, and 18 over 2 I already have. That reduces to 9. So that's all of my possible rational zeros, which is, if you count, I think I have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2. So I have 18 possible rational zeros. So remember, if you have any of those rational zeros, you would be able to see those in your calculator. Okay, so is x plus 5 a factor of that polynomial? And we're supposed to use as many methods as we possibly can. So off the top of my head, I can think of 3, one of them being synthetic division. So I can synthetically divide by the possible 0, -5. So if you look in your list, -5 is not a possible rational zero. So I'm going to take a wild guess and say that -5 is not a 0. Also make sure this is a cubic function. So when you put these numbers up here, the coefficients, you should always have one more than the highest degree. So in this case, I have 4 numbers, 2, 11, 4, and 18. My highest degree is 3. That means all of my coefficients were accounted for. So bring down your 2, multiply, add, multiply again, add, multiply again. And right here, since the remainder is 23, x plus 5 is not a 0. Actually, x plus 5 is not a factor. X equals -5 is not a 0. So a second method would be to actually plug in the potential 0, x equals -5 into the actual function. So I would have f of -5 equal to 2 times -5 to the third plus 11 times -5 squared plus 4 times -5 plus 18. Here I'm going to get 2 times -125 or -250. I'm going to have a positive number here. 11 times 25 is 275 minus 20 plus 18. If I put that in my calculator, I get 23. So there's a second method. Your third method would be to graph and see that x equals -5 is not a 0. So there's 3 methods right there for determining whether a certain factor is a factor of the polynomial. All right, so we're going to get into this idea of what we call optimization problems. Optimization means you're looking for the maximum or the minimum values. So think of a quadratic function. A quadratic is either going to have a high point, which would be a maximum, or a low point, which would be a minimum. So here's your steps. Again, make sure you have your calculators. We're going to create a primary equation, which is the thing that you actually want to find. Then we create a secondary equation. So we're going to have a system of 2 equations. We're going to rearrange the secondary so we can use substitution. We'll simplify the new primary, and then we're going to calculate the vertex, which will give us our maximum and minimum. All right, so this first one starts off, if we were actually in person fully, then I would have you sit and do some guessing and checking on this one with some table groups, but since we're probably still hybrid, we'll go ahead and do this just by hand. All right, suppose you want to build a fence that will encompass the largest area possible. So right there is your primary equation idea. You have 65 meters of fence to use, and the fence must be in a rectangular shape. And we're looking for the dimensions of the fence. So again, if we were sitting in person, all of us together, we would just do some trial and error and see if we can come up with our numbers. But we're going to go ahead and do it by hand. All right, so I don't know my dimensions, so we're going to call the length x and the width y. So my primary equation is length times width, or x times y. My secondary equation comes from the idea that I have 65 meters of fence. So 65 meters is my perimeter. So I'm going to have my secondary equation, the perimeter, which is double the length plus double the width. So that's my secondary equation. So now what I need to do is I need to take that secondary equation and I need to solve it for either y or x. And then I'm going to plug it into that area equation, which is my primary. So I'm going to choose to solve this one. I guess let's solve it for y. So 65 minus 2x equals 2y. If I divide everything by 2, I get 65 over 2 minus x equals y. So this is why you're going to need your calculator, because you're dealing with fractions and or decimals. So now I take this equation right here and I use substitution and I plug it into my area equation. I'm going to go down here and do that. So I have area equals x times 65 over 2 minus x. So if I go ahead and distribute the x, I have area equals 65 over 2 times x minus x squared. So now you know we have a quadratic here, and it opens down, which means we're going to have a maximum value for the vertex. So the next thing I'm going to do is I'm going to take my quadratic, that I just wrote, and I'm going to calculate the vertex. So from here, I know that my A value is -1. My B value is 65/2. And my C value is equal to 0. So back from quadratics, I know my vertex is equal to the opposite of B over 2A, which is going to be -65/2 over 2 times -1, which is 65/2 negative over -2, which if I multiply by the reciprocal of -2 on the bottom, I get 65/4. So if you want to go ahead and change that to a mixed number or even a decimal, since we're talking about measurements, you're going to get 16.25 meters. So remember, that's your X value. So now I need to find my Y value. But the way I do that, keep in mind, that if I wanted to actually calculate my maximum, I would have to plug that back into the quadratic, but I'm just really looking for my dimensions. But I'm going to go ahead and show you how to find that maximum area as well. So when I do that, I need to go to this formula and use my quadratic, because remember, I'm calculating the vertex. So I could now do my maximum area is 65/2 times that X value, which is 16.25, minus 16.25 squared. So this is where you'd want to pause it and plug it into your calculator and make sure you're getting the same answer that I do. So I get my maximum area as 264.0625 meters squared. So the problem doesn't ask me for my max area, but the rest of the problems probably are going to, or I go ahead and calculate them for you. So if I want to figure out now what my other dimension is, I can take my 264 area and I can divide it by my X value, my length. And if I do that, I get 16.25 meters. So it asks for my dimensions. And it just so happens that this is a square. So 16.25 meters by 16.25 meters. If it asked me for the max area, I would have that at 264.0625. And if you look at the problem, it says the fence must be rectangular. Well, we all know from geometry that all squares are rectangles, but not necessarily all rectangles are squares. So I do have a rectangular fence, which just happens to be a square. All right, so a lot of calculations going on in these next 2 days, so be prepared. All right, so this next one says the sum of the first number and twice the second number is 40. Find two positive numbers so that their product is a maximum product and then I want to know what that maximum product is. So again, this one could be one that you could just guess and check, but as we go on, you're not going to be able to guess and check the answers. So we're going to go ahead and do it the way we're supposed to. All right, so my primary is the product. So if I say X is the first number and Y is the second number, then I'm going to call P my product as X times Y. So there's my primary. My secondary is sum of the first number and twice the second number is 40. So I'm going to have X plus twice the second is equal to 40. So I'm going to take my secondary equation and I'm going to solve for a variable. So I'm going to go ahead and solve for X. And then I'm going to take that and I'm going to plug it into my primary equation. So now I have P equals 40 minus 2Y times Y. Or if I distribute, I get 40Y minus 2Y squared. So there's the quadratic that I need to calculate my maximum for. And again, that's a quadratic that will open down because of the lead coefficient being negative. So my A value is -2, my B value is 40, my C value is 0, and I don't need that. So remember that when you solve this one, you're solving for Y. So Y equals the opposite of B over 2A, which is -40 over 2 times -2, which is going to be 10. So now I need to go back here to my quadratic, because remember I'm calculating what I think of as my vertex, and I need to figure out what that maximum product is by calculating my vertex. Okay, so I know Y. So I know P is equal to, there's my quadratic, 40 times 10 minus 2 times 10 squared. So my max product is 400 minus 200. So my max product is 200. So in order to get my second number, I know P is equal to XY. So I know 200 is equal to, I know my Y term is 10. So I know my X term, which is my first term, which is 20. So my max product is 200. My first number is 20. That was my X value. If you go back and look at my variable assignments, and my second number is 10. So if you go back and check, first number plus 2 times the second should be 40, and that works because I would have 20 plus 2 times 10, which is going to give me 40. All right, that one wasn't too bad. All right, so for a third one, this one says a farmer has 600 meters of fencing, which will be used to enclose a rectangular pen adjacent to an existing wall. He'll use the wall as one side of the pen and the fencing for the remaining 3 sides. Find the maximum area. So here's your primary. And then the 600 is going to be used for your secondary. So pictures always help. So here's my wall. I don't need a fence there. but I do need 3 sides of my fence. So it's rectangular, so I'm going to make this side X, and this side Y. So again, for my primary is going to be my area, so X times Y. And then for my secondary, I can use the perimeter. So 2X plus Y equals 600. And I'm going to solve this for Y. 600 minus 2X. So now I can take that, oops, and I can plug it into my area formula in place of Y. So I have area is X times 600 minus 2X. Here's where I get my quadratic. 600X minus 2X squared. So again, I'm going to calculate my vertex. That's a parabola that opens downward. Hence, I get a maximum out of it. So my A is -2, my B is 600, and my C is not needed, but it's 0. So if I calculate my vertex for max, I'm calculating for my X variable, so X is equal to the opposite of B over 2A. So I get 600 over 4, negative 600 over 4, negative 4, which is, if you divide that out, you get 150 meters. So I know that my X value, or the length of my rectangle, is equal to 150. So again, remember, you're calculating the vertex. So you need to plug in that X value into the quadratic. Don't go back and plug it into the 2X plus Y. So my area, I'm going to calculate my max area. It's going to be 600 times 150 plus 2 times, or minus 2 times 150 squared. For my max area, using my calculator, I get 45,000. So there's my max area. I know my X is equal to 150. So if I take that, I know area is equal to X times Y. So 45,000 is 150Y. So Y is going to be equal to 300. So my dimensions, length is 150 meters, width is 300 meters. So again, be sure to go plug that first value of your vertex or your maximum. Make sure you plug that back into the quadratic, because there are times plugging it into the secondary equation isn't going to work for you. All right, so that's all for today. I believe tomorrow we have 3 more of these fun problems to do. So have a wonderful day.